Alright, in this video we are going to write piecewise functions and absolute value functions given the graphs. So starting with this one, so we need to write a piecewise function for this picture. So we know a piecewise function is going to start off like f of x equals, and we'll do a brace, and then here's where we will write the two pieces. So let's start with this piece. Alright, I'm going to color code it for you to make it easy to follow. This will be my blue piece over here, and this will be my pink piece. Alright, this open circle. Alright, so let's do the blue piece first. Now, notice how this is a horizontal line at 1. Alright, that is the equation y equals 1. So I'm just going to put a 1 for that piece because of y equals 1. Now, both of these graphs are the point of discontinuity. The break here is at -2. So for that reason, I'm going to say if x is less than or equal to -2. Alright, because it's to the left of -2, and this is a closed circle, so I will include the -2 with an or equal to. So that's it for the blue piece. That's done. Now the pink piece is a diagonal line, so this is going to have more of a y equals mx plus b equation, a little bit. The slope, it's going up 1 over 1, so the slope is just 1 over 1, which would be 1x, or just x. Now the y-intercept is 0, so I'm not actually going to put any number on the end. So it's just y equals x. So for that reason, I can just put x for my second piece, because y equals x. Now I will say if x is greater than -2. Again, the break is at an x value of -2, and it's to the right. I will not put an equal to sign because it is an open circle. Alright, number 10 is in 3 pieces. So I'll use 3 different colors just to make it really clear. Alright, so we'll have the blue piece, and then we'll have this pink piece. Yeah, that's nice. And then how about a nice green piece? Save the whales, green piece. Save the whales. Alright, so let's do the blue piece first. That was a horrible brace. We can do better than that. Okay, so our 3 pieces. Let's start with the blue piece. Now the blue piece is just a horizontal line at -2. So when you look at that, you should be thinking y equals -2. So as far as the piecewise function, you're just going to put -2. Now, look at the x value here. The x value of this is -3. So this is going to be less than or equal to -3. So I'll say if x is less than or equal to -3. So that's it for the blue piece. Okay. Now let's do the pink piece. Alright, now the pink piece is a diagonal line, so you should be thinking like y equals mx plus b. So the slope, see how this is going down 1 over 1? So that's like -1, but -1x is just -x. And then the y-intercept is clearly 4. So that would be -x plus 4. So that'll be the equation for the pink part, will be -x plus 4. Now if, okay, so the x values of this pink part, so looking at the x-axis, it goes from here to here. Alright, that's -3 to 0. So if you have a part of the graph that goes between 2 values, you do it like this. I'll say -3 is less than x, which is less than 0. Notice I did not say or equal to. These are both open circles. Okay, so that's it for the pink piece. Now for the green piece, again, this is a diagonal line, so we're thinking y equals mx plus b. This is going up 1 over 1, so that is a positive 1. 1x is just x. The y-intercept is 0, so I'm not going to put plus 0. I'll just leave it as y equals x. So that's why for the green part, I'm just going to have x if. Now, so the x value here is at 0. So I'll say if x is greater than or equal to 0, because it's going to the right of 0. So that would be it for number 10. All right, so 2 more problems. So if we want to write an absolute value function for this graph, what you want to do is start with the vertex. Now, for an absolute value equation, we know where the vertex shows up. So I'm leaving a little space here for slope. Come back to that. Okay, the vertex shows up here and here. And it's always the opposite of this gives us the x value. So if this is 1, then that would come from having an x minus 1 right here. And then the y value is this number right here, exactly the same. So this is a positive 3, so I'll put a positive 3 right here. So this gives us the majority of the absolute value function just comes from the vertex. All right, it's the opposite of this one and then that one. So the opposite and then that one. But there, now we just have to worry about the number in front. So it's all about the slope of the right-hand side gives you the number in the front. And see how this is going down 2 over 1? So this is the slope of negative 2. And you can definitely catch the fact that it's a negative, besides the fact that the right-hand side is going down 2 over 1. Maybe you accidentally looked at the left-hand side and you thought it was going up 2 over 1. But just remember, if the overall v is upside down, you know it's going to be a negative number in the front. Okay, so that's the absolute value function. Now, in order to write a piecewise function, which we're also supposed to have, again, we can look at it as 2 pieces. This will be my blue piece over here on the left, and this will be the pink piece on the right. All right, both of these are linear, so you should be thinking y equals mx plus b. So look at the slope of the blue part. See how it's going up 2 over 1? So that's a slope of 2, so that gives us y equals 2x so far. Then all we need is the y-intercept, but the y-intercept is right here. It's at 1. So we have 2x plus 1. So that's the first piece of our piecewise function. So I'll go ahead and start making it. All right, so the first piece will be this 2x plus 1. If. Now look and see that the axis of symmetry is at 1. So to the left of 1, it's blue. To the right of 1, it's pink. So since the blue part is to the left of 1, we'll say if x is less than or equal to 1. So now let's do the pink part. So this is a line, so you're thinking y equals mx plus b. If this is 2, then this is going to be negative 2. It's going downhill, so make sure you make it negative. It's down 2 over 1. So that gives us negative 2x to start off with. All we need is the y-intercept now. So I might as well go ahead and write this down, negative 2x. But we need the y-intercept. If I go backwards and go up 2 over 1, and then if I go up 2 over 1 again, then the y-intercept is going to be right here at 5. So that makes this negative 2x plus 5. And I will say if x is, now this pink part is to the right of 1, so I'm going to say greater than 1. Now it doesn't matter which one you pick to be or equal to, just pick one, it doesn't matter. Just you should make sure you have one of each. So that's it for number 11. Okay, and finally number 12. Now this is actually multiple choice, but we should let's just go ahead and write a piecewise function, and then we'll just look and see which one it was. So let me color this piece blue. All right, so this will be the blue piece, and I'll color this piece pink. So that'll be my pink piece. All right, so the piecewise function is going to have these two parts to it. So I'll say f of x equals, I'll make the brace. All right, so for the blue part, think y equals mx plus b. See how this is just going down 1 over 1? So that's a slope of -1, so I'll just put negative x. The y-intercept is here at -3, so that makes it negative x minus 3. So I have negative x minus 3 here. Now, now the cutoff value is here at 0. It's right at the y-axis where it changes from one to the other. So it's the blue function to the left of 0. So I'm going to say if x is less than or equal to 0. This one had to be or equal to because this is a closed circle. So that's it for the blue part. Now for the pink part, again think y equals mx plus b. So the slope, see how it's going up 1 over 2? So that's positive 1/2 x. The y-intercept is clearly 1, so that's 1/2 x plus 1. So we can just write 1/2 x plus 1 right here. And I'll say if x is greater than 0. Again, both of them, the point of discontinuity is at 0. This one is to the right of 0. And it's an open circle, so I'll just leave it greater than. So this is what the answer should be. So now I'm just going to look for this down below. Okay, see, all of these mention 0. So let's look for the ones that have negative x minus 3. Okay, so this one has it, so that's possible. Does it have 1/2 x plus 1? It has the 1/2 x plus 1 as well. So this choice A is looking pretty good. Let's see if it's less than or equal to 0 and then greater than 0. Less than or equal to 0 and greater than 0. So choice A matches perfectly what we have right here. So that means choice A. This is the answer.